Hi, I'm Tom Henriksen from the DevOps Online Summit. Today, I'm joined by Chris Riley, a senior tech advocate focused on DevOps at Splunk. Now, Chris, you're a familiar face to many of us here at the DevOps Online Summit, but just a level set, why don't you introduce yourself to the people here?
Yeah, thanks, Tom. It's always fun chatting with you, and I really enjoyed participating in the events. I think the last two, as a matter of fact.
Yeah.
So I'm a DevOps advocate at Splunk, and a lot of people ask what that means. It basically means my career as a developer was not fantastic, but I could not give up kind of my obsession with the process, automation, and everything around building better quality software faster. And so now I spend a lot of time around thought leadership, engaging with enterprises who are trying to solve this problem, both the unicorns and the ones who are just now thinking about moving to the cloud. Yeah. And so I get to have a lot of fun doing that.
Yeah, that's a lot. I like how you put it, I think, on your LinkedIn, like bad coder learning, how you phrase that, but it's pretty funny for people to check out there. So, but today, Chris, you want to talk to us about observability. And this is something, a lot of us are hearing about, but I thought we'd bring you on here and kind of give us kind of the basics. So to start us off, Chris, what is observability?
Yeah. So I consider this an elephant in the room, and that is anytime there's a new term in the industry, if you're a good curmudgeon-y techie, and you hear the term, and your first reaction, and it's usually my first reaction as well, is like, that's not new. I'm not going to use that term. I did it for DevOps, and now I have backgrounds that say DevOps. And that's just kind of the nature, and it's healthy, I think, to do that. And so the first thing I just want to say is, when does it matter that we start using new terminology? Because it's important to be precise. And that's why I appreciate you asking me what the definition is. It matters to me when there is a unique problem space, and that problem space is big enough that you need a term in order to be efficient in your conversations about it. I mean, I try to be very tactical about that. So what is the problem space? Well, the new problem space is this. Modern applications have become so distributed, ephemeral, stateless, that a operator, because we still have operators, people who manage these applications, cannot conceptualize the application and hold a model of that application in their brains. It's moving too quickly. It's just impossible for somebody to be like it was in the old days, where you had the Billy Bob server and you knew exactly how that thing behaved. Every 2 weeks you restarted it and you went right to the event log. You knew what it was going to be, and you addressed it. So that is a new problem set. We have to deal with highly distributed applications. And I hesitate to use this term new, because eventually new becomes old. But applications have fundamentally changed. Observability is a practice of monitoring. So we are talking about monitoring. But the reason we use this term observability is because it is a new nature and there's new challenges. And we have a fundamental shift of pull versus push. So in the traditional monitoring days, pull worked. We thought about infrastructure. We could start with the log because we knew where the log was. That doesn't work anymore. In the new model, it has to be pushed. Like I said, nobody can hold these models in their head. They need to be pushed incidents, and they need to be directed where the actual problem is. Because when you have many services and all those services are interrelated, the one particular service that throws an error or an event may not be the source, the root cause. So that's when we get to an observability. And observability is first that mindset. Second, the technical capabilities that help you address these new set of challenges. I understand that definition is not maybe the most widely accepted definition, so I'll give you what that is. The most widely accepted definition is based on the data itself, which is traces, spans, metrics, and logs. So observability in that definition is the data, but I believe that it's much more than that. It includes incident response strategy. It includes the practice of visualizing this data, et cetera.
Interesting. So you mentioned it's a practice of monitoring And as you kind of mentioned too, some of us curmudgeons might think, oh, this is nothing new under the sun here. But tell us, with observability, why should we use this term, and where does it, because you brought up a little bit about, you alluded to where the practice or the problem space, as you said, but what are some of the benefits and why we should use it?
Yeah, well, some of the challenges I've seen companies run into as of late is they have a monitoring function inside their organization and they rename it observability and they don't change anything. And they don't even have Kubernetes. Yeah. So there are some very clear kind of things that are assumptions that come with observability. Number one is that it's cloud native. You're building a cloud native application. You're deploying it on the cloud, and it was built for the cloud. You certainly use observability when you start to break apart your monolithic applications, but it's generally more associated cloud native, which at the next layer is microservices, which implies Kubernetes. So these truly are kind of elements that you assume are there when you're talking about observability. A typical enterprise is going to have a traditional monitoring practice and an observability practice side by side. One does not replace the other.
Yeah,
they're just two separate things, and hopefully they work together. But that's always kind of a challenge. And so I think just saying observability is the new name, find and replace observability with monitoring is not correct. It's certainly when you're dealing with those modern cloud native applications.
That reminds me, I've seen organizations kind of do a similar thing with their operations and just say, okay,
call it
DevOps.
Or SRE, yeah.
It's like, okay, we're going to replace this with this. And like you mentioned, change nothing. None of the practices change. It's just the same thing. So it's confusing to some, especially people. I always think about the people who are, job hunters that go out and look, and they're like, they think this role says one thing, but then they get in there and it's completely something different. But that's a different topic for another day.
Full stack engineering caused a lot of problems, I think, for organizations.
Yes. So with observability, how do we start using this? What are some steps or the way kind of lead us down that path?
Yeah. Well, I think any company who leads with tool first is not doing themselves a justice. You can't expect the tool to be the observability for you. It certainly accelerates and supports it. The first thing you have to think about is your data. How do you instrument the data? How do you get that data in? Everybody's heard the term garbage in, garbage out. I don't think the vast majority of people have really listened to what that actually means. So is in the world of monitoring, here at Splunk, we use an awful term called GDI, getting data in. It's like so practical of a term, but we still abbreviate it, which I think is kind of goofy. It makes total sense what it is. So you have to get the data in. And as a part of instrumentation, you have to think about the strategy for that. So in APM, for example, you can instrument at an agent level. You can instrument with an auto instrumentation library for whatever language you're using. Or you can instrument via the developer in code. What's interesting about that, what I just stated, is most organizations don't think about that. And usually they want to go, oh, we'll just do agents because it's the easiest thing to do. But agents give you the least resolution from a data perspective. The most resolution is going to come at a developer level if all of your developers are doing it in the same way and they're using the same tags and they're populating those tags with the same data. So that has a scale problem. And so this is where I'm trying to break apart. Like, it's really important to think about how you get the data in, because the best observability platform out there is only as good as the data it's being fed. And if you want to take advantage of the benefits of dashboards and all of that stuff, you really have to think about it. And there's a project out there called the Open Telemetry Project, which is an open source project with CNCF. And it really, I'm all in for this. It unshackles your infrastructure so that your instrumentation does not dictate what monitoring and observability practice you implement. So you decouple those and you can make it repeatable and consistent in your environment. So I'm really big on open telemetry. Logs are not fully supported yet. So that is a weakness, but it's coming. And I would encourage anybody to check and think about using open telemetry as a standard for their instrumentation. Now, after instrumentation, you have to think about how you create detectors and all of this stuff. So a lot of the things I'm suggesting are not related to the tool itself. It's related to information architecture, how you organize yourself. And really what you want to do is kind of get these things dialed in so that the platform, whatever tool you slipstream in, does the best job for you. Then the next challenge you're inevitably going to face is you have one engineering team who knows exactly what their service level objectives are and indicators are, and another one who doesn't even know what those mean. And you have to spend time reconciling that. And that's where the SRE role really comes in.
Yeah, that can be interesting. And earlier, as I was laughing, Chris, when you said getting developers to do the same thing. I was just thinking of herding cats. Sometimes developers can have strong opinions and don't always want to do the same thing.
Right. Absolutely.
So, but what are some of the pitfalls with using observability, Chris?
Well, I would say the first pitfall is expecting the tool to solve your GDI problem for you. It's not, and you got to think about that. The second, I guess, really comes back to this SRE function. If you don't have an SRE function, it's hard to do observability because they end up becoming the stewards of the observability practice throughout your engineering team. They are an embedded partner. And so they may not necessarily have to own all of observability. It's not about that. It's a deliberate effort to be stewards because picking your metrics, picking your service level indicators, all of that stuff is not intuitive and is not something that developers are constantly thinking about. So that not having that function is a pitfall. And it doesn't have to be called SRE, but it has to be that steward. Some organizations call it cloud architects. It's usually going to be those who are on call or responsible for setting up on call, what was previously the NOC for your environment.
Yeah.
The other one is over rotating on metrics, trying to measure too many things. Choosing your metrics matters a lot. We have a lot of guides out there with golden signals and red metrics, which is rate, error, and duration, utilization metrics for infrastructure, which was usage, saturation, and errors. There are some standards, but you will have unique metrics. You just don't want to over rotate. I think there's this tendency to let's just visualize all
everything.
Of it.
Yeah.
Yeah. And then none of it is meaningful. Or you focus on that one thing that doesn't matter. Because sometimes pegged CPU is just part of that service. It's by design, and it may not be an issue.
Yeah. Now, Chris, another thing you mentioned the tools there. Talk to us. So you work for Splunk. There's a lot of tools in this space, but tell us a little bit about the landscape there and maybe the pros and cons, or at least what are some of the things that for Splunk, for example, how does it differ from the other tools out there?
Yeah. I'll start there because I certainly don't want this to sound like a promotion. Splunk has the observability cloud, and as I mentioned before, we don't look at observability as just being traces and spans. We look at it as a set of capabilities that are necessary, which is on call, so incident response, absolute critical practice. You can't use ITSM approach with observability. That's a mismatch. You have to have a true on-call strategy. Outside of that, it's making sure that you have visibility at each layer of your stack. So that starts at infrastructure, then application infrastructure, which is Kubernetes, application business logic, API, and then your front end, real user monitoring. And so what Splunk is focused on, our vision is that we should be creating visibility, a thread throughout the entire stack. That's important. Now, that gets to the pitfall. The pitfall is people who don't think about weaving a thread through their entire stack because they get visibility silos. And you think, well, our developers are very efficient with their Prometheus dashboards and Grafana, really good at that. And the DevOps engineers have their thing. They understand it to a T. Well, that's not the problem. Developers don't like when they get interrupted. The best way to avoid interruptions, or I should say the other way, the best way to ensure that you will get interrupted is by speaking your own language that other people don't understand, because you have to communicate, especially in DevSecOps, which was a track at one of your events, and it's so critical. You have to all be speaking the same language. So I don't care how efficient a development engineering team can be at visualizing their stuff. They will get disrupted if they can't explain it effectively to other teams. Best way to be effective at communication is just creating a standard. And so there are a lot of tools out there. You certainly want to don't think about the visibility you have to create today, because you will solve that problem. You can solve that today. What you haven't solved for is where you're going. And so you actually need to be 2 steps ahead of your engineering team and your stack and your architecture in visibility. Otherwise, your monitoring practice is also what's going to stall your development and delay sprints. So when you think about the tooling out there, think about the technical capabilities you need, align and go identify the vendors that have those technical capabilities, and then think, how does that set me up for the future? Is the approach I take. And there's a lot of great technology out there. It's amazing.
Excellent. Chris, you've shared a lot. Any closing thoughts?
No, I first of all, I'd say that everybody out there is just being inundated with information. And in my closing thought, and I think that this is probably true when you do coaching from a career perspective, is that engineers need to get out of their ticketing system and the features that they're building and that one particular automation that they're writing, and really think about what they do and how it impacts the business. Because your application is a reflection of the team that built it. And that implies a lot of things. And it implies culture, and it implies business and so forth. So expanding your breadth there is going to help you as an engineer and help you in your career. And observability is just one component of that.
Excellent. Excellent. Thank you so much, Chris.
Thanks, Tom.
Don't forget to subscribe to our YouTube channel. On behalf of Chris Riley, I am Tom Henriksen for the DevOps Online Summit.